Okay, so today we're looking at arithmetic series, part 1. We're just doing some fairly basic examples of arithmetic series, remembering that the difference between a series and a sequence is what? This will be a good time to volunteer an answer. Yeah.
A sequence is just a number followed by a comma and then just it keeps going.
Okay.
This is a series is adding or subtracting.
Very good. So a series is just a string of numbers that follow some pattern, each number separated by a comma, but a series is an adding and subtracting operation. Okay? Yeah. An adding or subtracting operation. So we're adding or subtracting a whole string of numbers together. That's what we are talking about with series. Okay, so really what we need to do is learn two formulae, plural for formula, two formulae. The first one, if we can use it, we try to use it because it is the easier of the two to remember and
you can't
work
touch
with.
that. That's sexual
Tom.
assault.
So, now I like to be driven by formulas. That is to say, I like to start with a formula and work out what it is I need to make it work. So with this formula, N is standing for the number of terms in the series, A is standing for the first term, L is standing for the last term. So we would need to know what the first and last terms are. Generally, it is not a problem to know how many terms we have in the series that we are working with. So let's just record that. N always, it doesn't matter what series you're talking about, what type of series or sequence, N is always the number of terms. A is equal to the first term as usual, as it was with arithmetic sequences, and as it will be when we get to geometric sequences and series. And L, that's an L, not an E, L is standing for the last term. Okay. Now, that formula is useful in this sort of situation. If I wanted to sum, then maybe the even numbers between 2 and 200, it would look like this. You don't have to write, obviously, every term out. And that's enough information to indicate what sort of series it is. So, how do I do that? Well, firstly, I need to know what N is. Secondly, what A is. Thirdly, what L is. I don't think that's going to be too hard to find out in this case. So here, my recommendation always is, when you're working on a problem, is to write down the relevant formula. Okay, settles the nerves, gets you started. We would hopefully recognise that this is the formula to use. And then we'd identify values for each of the pronumerals. Firstly, I think I'd like to know how many terms are in the series. Yep?
100.
100. You've got to be a little bit careful, but I think this one's safe. It's just the sum of the even numbers between 2 and 200. That would be the same as just dividing 200 by 2, and I think that's a fairly safe bet in that case. Yeah.
So it's just the last term over the common difference, and that'll give you the amount of terms?
Yeah, okay. The last term over the common difference. Yes, that'll work nicely, won't it? Last term is 200, common difference is? 2. Yep, so 200 divided by 2 is 100. Alright, so N equals 100. A is staring us in the face. It is always the first term, so it is 2. And finally, going through my formula, this is what I mean by being driven by the formula. Just work out what it is you need. You need L, and that quite clearly is 200. So a bit of very basic algebra is all that's left. we say, therefore, boys, we're dealing with an equal sign there, so every line should start with therefore. The sum of our 100 terms, S100, is equal to the number of terms, which we've just said was 100, divided by 2, bracket.
200.
Yes, it is. It's 202. But so everyone can see exactly what's going on, where everything's coming from. We'll do it in full, like so. And then it's just tidying up. Therefore, the sum of the first 100 terms is equal to 50 times 202. Now, we don't need a calculator for that, of course, because we can go 202 times 50 is the same as that, isn't it? So that equals 0, 10, 0, 1, 10. It seems to be 10,100. Okay, and that's our first example, using that formula. Any questions? Okay. Can we hit the record button, please? Okay, so now we're moving on to the formula we use when we don't know the last term in a series, which is the usual situation, to be honest. So let's have a look at what happens there. Firstly, we need to know that formula. We need to kind of memorise that. There's no shortcuts there. But what might make it easier to remember is the similarity between it and the formula for finding the general term of an arithmetic sequence. That, you'll remember, was Tn equals A plus bracket n minus 1 times d. So what's different? Well, you've got a 2 times there, and then you've got the n over 2 outside of brackets. That's the only difference between that and the formula for the term of a sequence.
Hey,
Okay.
The other one had n over 2.
We're recording.
Yeah.
Okay. Now, so how do we use this one? Well, let's work with the series we were working with before, except just change the question a bit. So what I want to do here is maybe find the sum of the first 20 terms in the series 2 plus 4 plus 6, and it trails off. Now, it wouldn't be hard work at all for us to work out what the 20th term is in that series, but for more complex examples, that can be a bit of an effort. But really, that's all we need. That's the only information we need to answer that question. Once again, I like to start by writing down the relevant formula. So the relevant formula is right above us. That at least tells me, you know, that we are dealing with an arithmetic series and that you know the formula that is associated with it. Now, once again, we like to be driven by the formula. We scan it and see what it is we need to get this thing working. Well, I need to know n. I need to know a, n appears again there, and we need to know, in this case, the common difference. With that simple formula, we didn't need to know the common difference, but here we do. But that's okay. It's quite easy to identify the values for those pronumerals. So here we go. N will, in this case, be in the question. It's saying find the sum of the first 20 terms. So n is 20. And we know that the first term is staring us in the face again. It's 2. And the only other thing we need to know is D, the common difference. Now remember, the common difference is calculated by taking the first term away from the second, or the second away from the third, etc., etc. So, and by the way, you should realise that if 4 take 2 doesn't equal 6 take 4, you are not looking at an arithmetic series at all. It will not have a common difference.
If there's a question like that in a test, you just write cannot be done.
Yeah, well, yes. Quite possibly what you're looking at is a geometric series, okay, because they're the two series we deal with. If it doesn't satisfy the test for an arithmetic series or a geometric series, someone's made a terrible mistake. Okay, so it would be sensible to say it cannot be done. It's not an arithmetic or geometric series. Okay, good question. So D, I might just put the very simple working out down for that so that you know there's absolutely no mistake as to where everything's coming from. Okay, so N is 20, A is 2, D is 2 as well. So substitute those values in and we should have something. Now S, 20, so the sum of the first 20 terms is equal to, well we just said N was 20. We've got a square bracket there. 2 times A, so that's 2 times 2. Plus N take 1, so N is 20 times the common difference, which is 2. Okay, a bit of tidying up. In this case it's reasonably straightforward, but I would caution you to be careful where you've got negative signs going on. Generally down, well it could be anywhere here, but down here it's important to be careful because we know about the effect of negative signs outside of brackets and so on. Okay, so therefore, should have the therefore sign there as well. There's 20 equals 10. Now, I'm not really going to need my square brackets anymore, so I'll dispense with those. We only use square brackets when we've got brackets within brackets. 4 plus 19 times 2. Straight out, order of operations is what's at stake there. So, therefore, 10 is easy to deal with, that's good. 19 times 2, we do the multiplication before the addition. So it's 38 plus 4, it's 42, times 10 is 420. So what are we saying with that 420? This is what we're saying. We're saying that if we sum the first 20 terms of that series, which is the series of even numbers from 2 to so on, 2 to 40, isn't it? The sum of that series will be 420. So that's how we use, that's a basic example of how we use the formula for an arithmetic series when we do not know the last term. Of course, the last term in this case was easy to identify, and you could confirm that result by using the simple formula. Thank you.